Objective in this lesson is to help you identify complementary and supplementary angles when you see them. At the end of this lesson, we expect that you'll be able to identify them and also be able to solve equations that are relating to complementary and supplementary angles. To ensure that you keep getting our lessons anytime we create lessons, please do hit the subscribe button and also the notification bell. If you are viewing us via Facebook, do not forget to follow us and also like and share this with a friend. Let's start with complementary angles. Two angles are actually said to be complementary when both of them sums up to 90 degrees. Now, if you have a right angle triangle, for complementary angles, our focus is on the right angle triangle. If I have a right angle triangle this way, for it to be right angled, that means I have an angle here which is 90 degrees. This angle here is theta. Now, what do I have left here? Remember that your theta, let's call this alpha. Your theta plus your alpha plus 90 must equals to what? 180 degrees. So that theta plus alpha is equals to 180 degrees minus 90. I'm collecting like terms. 90 is going to leave here, come to the other side, becomes what? Negative. So that theta plus alpha is equals to what? 90 degrees. Now, if theta plus alpha is equals to 90 degrees, then both of them are said to be what? Complementary. They are said to be complementary angles. Now, let's see one unique characteristics of these complementary angles. If theta plus alpha is equals to 90 degrees, let's label this triangle. I call this triangle A, triangle B, and triangle C. For triangle A, triangle B, and C, you observe that this part, let's call this part as small c, we'll call this as small a, and we'll call this as small b. Using SOHCAHTOA, you observe that the side of theta, sine theta, is equals to opposite over hypotenuse. From this triangle, for theta, my opposite is A, my hypotenuse is what? Is B. So my sine theta is equals to A over B. The same thing happens to my cos theta. My cos theta will be equals to adjacent over hypotenuse. That's equals to, for theta, this is the adjacent C, and here is the hypotenuse B. So we say that that is equals to C over B. And now let's look at alpha. For the sine of alpha, you see that the sine of alpha, sine alpha is equals to opposite over hypotenuse. That's going to be C over B. And cos alpha is equals to adjacent over hypotenuse. That's going to be A over B. Now, from this above, it's clear that your sine of theta, that's A over B, is the same thing as your cos of what? Alpha. So we say that for complementary angles, the cosine of one angle equals the cosine of one angle equals the sine of the other. We can categorically state that sine theta is equals to cos alpha and is equals to A over what? B. Note that this condition is true for complementary angles. Let's see some example. Our first question is to solve for theta in this example. The cos of 2 theta is equals to the sine of theta plus 10 degrees. Now remember that we agreed that cos theta is equals to sine theta. Now, for me to see that cos theta is equals to sine theta, that tells me that these angles are complementary angles. And we also know that if take this to be your theta and take this to be your what? Alpha. That implies that theta plus alpha in complementary angles is equals to what? 90 degrees. So I'm saying that 2 theta plus theta plus 10 is equals to 90 degrees. So that 2 theta, 2 theta plus theta, that's 3 theta plus 10 is equals to 90 degrees. Let's collect like terms. 3 theta is equals to 90 degrees minus 10 degrees. 3 theta is equals to 80 degrees. So that theta is equals to 80 degrees over 3, which is equals to 80 over 3. I'll leave you to do that. Okay, let's punch our calculator. Somebody I should not leave you. Somebody's winking me. I should not leave you. That's 26.67. Theta is equals to 26.67 in degrees. Now let's see the second question. For my second question, the question I have here says that if cos theta, or sorry, sine theta, the sine of 3 theta is equals to cos theta minus 60 degrees. What is theta? Now, just like we did in the first case, for sine theta and cos theta to be the same thing, we know that both of them are complementary angles. So both 3 theta and theta minus 60 degrees must sum up to what? 90 degrees. 3 theta plus theta minus 60 degrees is equals to what? 90 degrees. In my exam, I would like to tell my examiner that I know that they are what? Complementary angles. They are complementary angles. Don't mind my handwriting. Now, so that theta now, 3 theta plus theta, that's 4 theta minus 60 degrees is equals to 90 degrees. 4 theta minus 60 degrees move to the other side. It becomes plus, is equals to 90 plus 60. 4 theta is equals to 150 degrees. Theta is equals to 150 over 4. That's 2 here is 2, 2 here is 75. 2 in 75, that's 37.5 degrees. Now let's see the third question. Our third question says for us to solve for theta in this equation. If sine 3 theta plus 30 is equals to cos 4 theta. What is theta? I'll advise you pause this video for like 2 minutes and put your hand and give this question a trial. Okay, let's look at it. For these two, actually, they're complementary. I will say 3 theta plus 30 degrees plus 4 theta is equals to 90 degrees. 3 theta and 4 theta added together, that's 7 theta plus 30 is equals to 90 degrees. 7 theta will be equals to 90 minus 30. So that your 7 theta is equals to 60 degrees. Theta is equals to 60 over 7, which is equals to 60 divided by 7. That's equals to 8.57 degrees. With this, I hope you can identify complementary angles when you see them. Let's get into supplementary angles. Now, for supplementary angles are actually angles, two angles that sums up to 180 degrees. What do I mean? We have our straight line. We know that the angle on our straight line, we have our straight line, and we know that the angle on our straight line is equals to 180 degrees. So that for my supplementary angle, if I have my straight line this way, if I take out an angle, let's call this theta, and the remaining here will be equals to 180 minus theta. Now, both this angle 180 minus theta and theta are said to be supplementary angles. If this place is 30 degrees, this place will be what? 150 degrees. Both of them are said to be what? Supplementary angles. Let's see their unique characteristics. Here, I want you to follow me carefully. Now, I want to draw the Cartesian coordinates. We'll use that to explain. Here is my y-axis, and here is my x-axis. Now, if on my y-axis, let's call this point my y, and here is my what? X. At this part, my x here is positive, my y also is what? Is positive. But at this part, my x here, the same from here to here is x, from here to here is also what? X. But here, x will be what? Negative. If x is negative at this side, I want to pick this point such that here marks y, here marks x. I've picked this point, here marks my x2, and here marks my y. Now, look at this. If I take a line down here, I've taken another line down here. These two triangles are similar triangles. Why? Because from here to here is y. It exists for both angles, for both triangles. From here to here is x, though in the negative direction. And from here to here so is what? Is x. They are both similar triangles. So that if I have theta here, I'll also have what here? Theta. Now, if I have theta here, I have theta here. I'm taking my angle this way. If you're measuring angles, we measure angles anti-clockwise. If here is theta, I'm going to take the other part of it, which is here, that's the supplementary part. Remember, here also is theta. So what I have left here is theta is 180 minus theta. That's the supplementary part. So that at the first triangle, let's call this triangle 1, and let's call this triangle 2. At the first triangle, remember this is y and this is x. Let's call this line z, and let's call this part z. With the first triangle, sine theta is equals to y over z. Here also is y. At the second triangle, okay, let's divide it so that it will be clear. Let's call this part the second part, and this is the first part. With the second part of my triangle, sine theta also is equals to y over z. So katwa, that's sine is opposite over hypotenuse. That's y over z. Now look at cos theta. I want you to pay close attention. At the first triangle here, cos theta is equals to x over z. But at the second part of the triangle, my cos theta is equals to minus, because the x here is negative, is equals to minus x over z. Tan theta is equals to, tan theta is in the first triangle is equals to y opposite over what? Adjacent over x. That's your y over x. At the second triangle, your tan theta is equals to y over minus x. tan theta is equals to y over minus x. Now, this is our deductions. For supplementary angles, sine of both angles are positive. They are equal. The sine of theta at the first triangle, at the first quadrant, and the sine in the second quadrant are both equal. For supplementary angles, the cosine of one is equal to the negative cos of the other. My cos theta here is equals to x over z for my first quadrant, and in the second quadrant, my cos theta is equals to minus x over z. My tan theta is equals to y over x in the first quadrant, and my tan theta in the second quadrant is equals to y over minus x, so that it's negative. Now let's take a question to illustrate this. Our question says, if sine theta is equals to 3 over 4, for 90 is less than theta and theta is less than 180, find cos theta. Now, since theta is between 90 degrees and 180 degrees, obviously theta is in the second quadrant. And if theta is in the second quadrant, that means theta is greater, is between 90 and 180. If sine theta, remember we said that if sine theta is equals to 3 over 4, theta obviously will be equals to the arc sine of 3 over 4. 3 over 4 is the same thing as 0.75. So that theta is equals to arc sine of 0.75. That's shift. That's 48. Theta is equals to 48.6. Now, if theta is equals to 48.6 in the first quadrant, then the supplementary part of it, the other part of it, to make it a supplementary angle, we'll be talking of 180 minus 48.6. That means for theta to lie between 90 and 180, theta here, our desired angle must be 180 minus 48.6, which is equals to minus 48.6. Which is equals to 131.4. Now, mind you, if I'm actually in an exam hall, I wouldn't expect you to go all the way looking for 131.4, because what the examiner wants you to look for is a cos of theta. And he has told you that theta is actually in the second quadrant. Now, since my theta is equals to 48.6, all I need to look for is negative, will be the negative of 48.6 in the second quadrant, which is equals to, if you use your calculator and find, which is equals to cos of 48.6, that's equals to 0. That means my cos theta will be equals to negative 0.613. If you check the cos of 131.4, you see that that is 131.4. That's equals to minus 0.6613. So we see the properties of both supplementary angles and that of complementary angles. Thank you for staying with us, and see you in our next lesson. Thank you.